The manifold absolute pressure sensor measures the pressure inside the intake manifold and sends that information to the car's computer. This is crucial because manifold pressure changes depending on engine load, throttle position, and speed. With the MAP sensor's data, the ECU can calculate the amount of air entering the engine and adjust the fuel injection and ignition timing for the ideal air-fuel mixture. At idle or low-speed drive, the pressure is low, so the ECU delivers less fuel. Under heavy acceleration, the pressure increases, and the ECU increases fuel delivery for more power. The mass airflow sensor, or MAF sensor, measures the exact amount of air entering the engine and sends that information to the car's computer. Since the engine's power depends on the correct balance of air and fuel, this sensor plays a role in efficient combustion. The ECU uses MAF sensor data to calculate the amount of fuel to inject into the cylinders for an ideal air-fuel mixture. At idle, when less air is flowing, it delivers less fuel. During acceleration, as more air rushes in, it increases fuel to maintain smooth power. This balance ensures smooth performance, fuel efficiency, and lower emissions. The throttle position sensor monitors the angle of the throttle plate, in other words, how far the accelerator pedal is pressed, and sends that information to the car's computer. This signals the ECU to know exactly how much air is entering the engine at any given moment. With the TPS data, the ECU adjusts fuel injection, ignition timing, and air intake to match the driver's demand. When you press the accelerator lightly, the TPS signals a small throttle opening, and the ECU supplies less fuel. When you floor the pedal, it signals a wide-open throttle, and the ECU delivers more fuel for maximum power. The TPS is also critical for automatic transmissions, as it helps determine the right shift points based on throttle input. The knock sensor detects abnormal combustion inside the engine, commonly known as engine knock or pinging. Knock happens when fuel in the cylinder ignites too early or unevenly, causing shock waves that can damage pistons, valves, and bearings. The knock sensor is usually mounted on the engine block and works like a microphone. It listens for the high-frequency vibrations caused by knocking and sends that signal to the ECU. When the ECU receives this signal, it immediately adjusts the ignition timing and the air-fuel mixture to stop the knocking. This protects the engine from serious damage while maintaining smooth performance.